is dough? Jorge here, and I'm going to tell you how to graph rational functions without a calculator. Alright, so step one, we're going to have to find the whole. So, in order to find the whole, you look at the numerator and the denominator to see if any two functions are the same. See, x minus 3 and x minus 3 are the same, so we can cancel those out. And we will have a whole at positive 3. Alright, after that, now we're going to have to find the vertical asymptotes. In order to do that, you're going to look at the bottom denominator to see if, to look at any functions that are left. Here we have x plus 2, so we will have a vertical asymptote at negative 2. Alright, now that we've found the vertical asymptote, now we're going to have to find out if there are any end behaviors or slant asymptotes. Now, in order to tell that, you got to look at the x's to see. So we have two x's here, so that's an x squared over 1x. So that means we will have a slant asymptote at some point in the graph. After finding the slant asymptote, we're going to have to also look for the horizontal asymptote. So, in order to find the horizontal asymptote, you got to... Alright, so in order to find... It is dough. I'm Jorge, and I'm going to tell you how to graph a rational function. So, the first step you're going to have to do is find the whole. So in order to find the whole, you look at the entire function to see if you have any two similar what would you call them? Like factors, yeah. So here we have x minus 3 and x minus 3, so we can cancel those out. And we will have a whole at positive 3. Now that's the x part. Now we're going to have to find the y part. In order to do that, you just plug the whole back into the equation. So we can do 3 plus 3 times 3 over 3 plus 2. So 3 plus 3 equals 6 times 3 over 5. And then 6 times 3 equals 18 over 5. So we will find the y coordinate at 18 over 5. Alright, now after that, we're going to find the vertical asymptote. In order to find the vertical asymptote, you look at the bottom denominator and look at any factors that are left. Here, now we have to make this whole factor into 0. In order to do that, we put a negative 2 in place of x to get the vertical asymptote. So that will give us a vertical asymptote at negative 2. Alright, now that we've found the vertical asymptote, we're going to move on to find if there's a slant asymptote. Now, in order to find a slant asymptote, you look at the x's on both the numerator and the denominator. So here we have two x's, so that's x squared over 1x. So that means we will have a slant asymptote. In order to find that slant asymptote, you're going to have to use long division. So, I'm going to set it up like this. So we're going to put the top equation into here. So we're going to do x, plus, should we?
Squared.
Oh, let's do that. Alright, so now we're going to do x squared plus 3x.
There you go.
Alright, now, and then we'll have the bottom equation on the outside. So x plus 2. So now we have to turn this equation into that. So how will we get x to x squared? So we're going to multiply both by an x. So we will get x squared plus 2x. So we're going to subtract that. These cancel out, and that leaves us with x. But that does not matter. All that matters is the x, right? No?
Multiply it out.
Multiply it out.
Cut.
Alright, now to get x out, we're going to multiply it by 1. So now we're going to get x over x plus 2. So that's going to cancel these out and leave us with 2. So now we have x plus 1 as our slant asymptote. So we'll come back to that. Now we're going to find out if these are going up or down. Either to find out, you multiply, plug in the equation by 2 points near the vertical asymptote. So here we have -1, here we have -3. So if we go back here, we can do -1 plus 3 times -1 over -1 plus 2. So we'll get 2 times -1 over 1. So that will equal -2 over 1, -2. So here it's going down. So now we'll do the same thing. Here we have -3 plus 3 times -3 over -3 plus 2. That should equal 0 times -3 over 1. So now we'll get 0 over 1. So that will be going up, right?
Cut.
Alright, so what we can see here is we actually found an x-intercept. So in order to find out, we're just going to get closer. So now we're going to do -2.5. So I'm going to go over here, do -2.5 plus 3 times -2.5 over -2.5 plus 2. That should equal 0.5 times -2.5 over over 0.5, -0.5. So then we'll just multiply this, which should equal
I got you.
a negative
Point.
timeout.
Cut it. Cut it.
Alright, so we don't actually have to solve this because we can see that there are 2 negatives, one on top and bottom. So it should equal out to be a positive. So that will tell us that here it should be going up. Alright, now that we've found which ways they're going, let's find the x-intercepts. So in order to find the x-intercepts, we're going to plug in. We're going to make the x's 0. So, man, I'm running out of space. So we're going to do 0 plus 3 times 0 over 0 plus 2. So that should be 0 over 2, which equals.
Cut it.
Oh no! So now we know there's going to be one at -3 and one at 0. Alright, now that we've found all this, all we have to do left is plug in the slant, which is x plus 1, into the equation. So we can just go here and it's probably just going to be like that.
Cut it.
Cut it again. Right. So now we're just going to put in the slant. So now we've put in the slant, we can figure out that this should go down like that. And same thing with this. Alright.
Got it.
Again. Right. So now we can graph it. So they have to go through the X intercepts. So knowing this goes up, just gonna go through there. And that should be our graph. We can see the slant going through both of them. And you can see the important part of the graph is not here, but the further down it gets closer to the vertical asymptote. Or the slant asymptote. So, yeah. We're missing one part. That's okay. So 3 3/5. So we're gonna go here and then up to 3 and a little bit higher. So it should go like that. Boom. Woo!